This is the video for Accelerated Geometry on Section 19-1 on multiple representations of functions. The essential questions are: how do you translate between various representations of functions, and how do you solve problems using the various representations of functions? There are 4 different methods that we will be using. The first is what we call a verbal description. So for example, I could say verbally that an amusement park manager estimates daily profits by multiplying the number of tickets sold by 20. This is a verbal description. But you could take the same verbal description and write an equation where P is the profit and N is the number of tickets sold. So it says that the profit is made up by multiplying the number of tickets, N, by 20. So that's how we got the P equals 20 times N. We could also make a table where we could come up with the number of tickets sold and then find the profit. So 50 times 20 would give me 1,000, 100 times 20 would give me 2,000, and so forth. Or we could actually graph it. So we could take our equation, P equals 20N, and make a graph so that we can look at the graph and analyze it. These different representations can help the manager set, compare, and predict prices. So our first set of examples, we want to sketch a possible graph to represent the following. Now, just because I have the graph that I have on here doesn't mean it's the only graph that is acceptable. Keep that in mind. So the first thing is that ticket sales were good until a massive power outage happened on Saturday that was not repaired until late Sunday. So think about what will happen to the ticket sales if there's a power outage on Saturday, but it's not repaired until late Sunday. That's going to tell you that it's going to show a decrease of sales until Sunday, because the number of tickets aren't going to go back up until after the ride is fixed. So what we could do for this graph is we have Friday up here. So Friday sales were pretty good. Then Saturday we had the massive power outage, so it's going to drop quite a bit. And then it's going to drop again because it still wasn't fixed. But then we fix it on Sunday, so then the prices are the numbers tickets sold, which means our sales are going to go back up. So basically what I would want to see in your graph is that as long as you show me a graph where there's a decrease in sales until Sunday, so Friday we were up high and then it decreased Saturday and Sunday and then started going back up on Monday, then your graph would be correct. Let's try another. It says the weather was beautiful on Friday and Saturday, but it rained all day on Sunday and Monday. So in this case, Friday and Saturday sales are going to be good, but then Sunday and Monday sales are going to be bad. So again, I would want to see a decrease in sales on Sunday and Monday. So for example, we could say Friday and Saturday were pretty good, and then all of a sudden it dropped because it rained on Sunday and on Monday. Let's try one more. Oops. Okay, so the last one says only half the rides were running on Friday and Sunday. So that tells me on Friday you're probably going to have a decrease in sales, and on Sunday you're going to have a decrease in sales. So our graph could look something like this. Friday we have a really big drop in sales because half the rides were running. all of them are running back on Saturday, so our sale price, our tickets are going to go up, which means our sales are going to go up. But then on Sunday, they're going to drop again because half the rides were running again. And then on Monday, they're probably coming back, so the ticket or the sales are going to go up because the tickets are going to go up. Because each representation of a function, words, equation, table, or graph describes the same relationship, you can often use any representation to generate the others. So for example, we have Janet is rowing across an 80-meter wide river at a rate of 3 meters per second. We want to create a table, an equation, and a graph of the distance that Janet has remaining before she reaches the other side. And then we also want to answer the question is, when will she actually reach the shore? So the first thing we're going to do is we're going to create a table. So the first thing I want to do in creating my table is identify what I'm going to let my variables be. So I'm going to let t be the time in seconds. And I'm going to let d be the distance in meters. So we know that at the starting point, she's at 80. So I know when t is 0, the distance is 80. Well, after 1 second, well, no, then it says that she has a rate of 3 meters per second. So in 1 second, she's already gone 3 meters. So 80 minus 3 would give me 77. So we know that at 0 seconds, she still has 80 meters to go. After 1 second, she's going to have 77 meters to go. After 2 seconds, that'd be 80 minus 6, which would be 74. 3 seconds, she would have 71, and so forth. So we can create our table, and your table is going to look like this. Where after 0 seconds, she went 80, 1 second, 77. So it's the same thing that we just did over here on the side, but just putting it in a table format. The next thing we want to do is to write an equation. So to write an equation, we're going to come up with a way to fill in our variables. So I know that the distance she has left is equal to the 80 that she started with minus the 3 meters per second. So distance we said was going to be d. Equal to is just equal to. 80 is 80. Minus means subtract. And 3 meters per second, well, t was representing time in seconds. So then that's going to be minus 3t. So then we have our equation of d equals 80 minus 3t. Next thing we want to do is to find our x and y intercepts of the graph. Well, if we have d equals 80 minus 3t, your y-intercept is when x is 0. So in this case, we would find d when t is 0. So we have 80 minus 3 times 0, so we'd get 80. So this is our y-intercept. Our x-intercept is when y is 0, so in this case it's d. So we'd have 0 equals 80 minus 3t. So negative 80 equals negative 3t. Divide by negative 3, so that negative divided by negative is going to be a positive. So it's roughly 26.67 is t. So this would be our x-intercept. So that when I graph, you have at 80, because this would give me the ordered pair of 0, 80, and this gives me the ordered pair of 26.670, which are these 2 points here, and then we connected them to get our graph. So then the last part of the question says, when will she reach the shore? So in other words, when will the distance that she has left be 0, which in this case would be our x-intercept. So the overall answer to the question is that she'll reach the shore in about 26.67 seconds. All right. Sample 5 says the table shows the height in feet of an arrow in relation to its horizontal distance from the archer. Create a graph, an equation, and a verbal description to represent the height of the arrow with relation to its horizontal distance from the archer. So we have a table. The first thing you want to do is to find your differences. So you're going to check first things first, check the first differences, and if that doesn't work, check the second differences. And in another example, I'll show you what to do if neither of those work. So first things first, 59.8 minus 6.55 gives me a first difference of 53.25. 90.55 minus 59.8 gives me 30.75. 98.8 minus 90.55 gives me 8.25. 84.5 minus 98.8 gives me negative 14.3. And then 47.5 minus 84.5 gives me negative 37. So this is our first differences. Since our first differences are nowhere close to being a constant, this is not a linear function. So I'm going to find the second differences. So now I'm going to do 30.75 minus 53.25, and I'm going to get negative 22.5. 8.25 minus 30.75 is negative 22.5. Negative 14.3 minus 8.25 is negative 22.55. Negative 33 minus 14.3, or negative 14.3, would give me negative 22.7. So these are our second differences, which tells me that since it is the second difference that's close to being a constant, that this is going to be a quadratic model. Okay? So next step we're going to do is refresh ourselves on putting information in our graphing calculator. So what you want to do is you want to hit your stat, edit, and then in L1 you're going to type the distance. So in L1 you're going to have 0, 75, 150, 225, 300, and 375. In your L2 you're going to type in the 6.55, 59.8, 90.55, 98.8, 84.5, and 47.5. So pause the video and go to stat, edit, and type in your information in your L1 and L2. Once you have your information, into L1 and L2, we've already decided that it is a quadratic model because our second differences are the constant. So then you're going to go back under stat, and you're going to go over to calculate. And then you're going to go down to number 5, which says quadratic regression, and hit enter. And some of your calculators may have you hit enter again. So enter it until you see the screen that looks like the following. So when you finally have this screen that says your quadratic regression model is y equals ax squared plus bx plus c, it tells you what your a value is, your b value is, and what your c value is. So then you're going to write your regression equation, which is going to be y equals, the a was negative 0.002, the b was 0.86, and the c was 6.52. So this is our model that we're going to use. Okay. The next thing you want to do is make sure that your stat plot is turned on. So to do that, you're going to hit second, y equals, where it says plot 1, if it says on, you're good to go. If it says off, then you need to hit enter. And then highlight on and hit enter. And then you're good to go. So once you do that, you're going to go back to y equals. You're going to type in your quadratic regression equation. Once you have your quadratic regression equation typed into y equals, the next thing you're going to do so that you can see the whole thing with the equation is hit zoom and scroll down to where it says zoom stat. And that'll allow you to see your points along with your actual equation, your graph, your line, your quadratic. Which looks like it is option number 9. Says zoom stat. So then your graph should look something like this. You should have your points along with the actual equation that you typed in. So now we have our equation that we wanted, we have our graph that we wanted, and the last step is to write our verbal. So our verbal would say something like, the archer shoots the arrow from a height of 6.52 feet, and I got that because at 0, he was at 6.55, but in our equation, the C value here was 6.52, so when I plug in 0, you're going to get out 6.52. So you're going to go with what your equation says. So he shoots it from a height of 6.52 feet. It travels for about 220 feet and peaks at about 99 feet. So how can I calculate that? You can calculate these two numbers. So the 220, 99 came from calculating the maximum. So if you want, you can pause the video and hit second, calculate maximum, and you should get this point. And then it lands on the ground about 500 feet away. So it lands right here, which is about 500 feet. Now, if we really wanted that point, we could calculate it in our calculator as well. So just as a refresher, there are 4 different ways that we have been representing, which is a table, a graph, an equation, and a verbal description. This little chart just kind of helps you try and figure out what you need to do. So if I'm given a table, I'm going to find the differences, I'm going to graph them, and then I'm going to perform whatever regression I need to do. If I'm given a graph, I'm going to identify which parent function it mostly resembles, and then identify the key points, whether it's intercepts, the max, or the min. I locate several points on the graph to make a table of values. I'm going to use the slope, the increase and decrease, or constant intervals to write a verbal description. If I'm given an equation, you can make a table of values, or you can use your graphing calculator to make the graph. If you're given a verbal description, identify which is your dependent and independent variables to write an equation. You can also generate a table and then stretch the graph. One key formula that we're about to use that will come in handy is your point slope formula of a line, which is y minus y1 equals m times x minus x1, where your m is your slope and x1, y1 is a point that is on your line. We'll come back to this in just a second. Also, remember that if your first differences is a constant, then you're looking at a linear function. If the second differences are a constant, then we're looking at a quadratic function. Example 6, we have a hotel manager knows that the number of rooms that guests will rent depends on the price. The hotel's revenue depends on both the price and the number of rooms rented. The table shows the hotel's average nightly revenue based on room price. Use a graph and an equation to find the price the manager should charge in order to maximize its revenue. So since I'm given a table, the first thing I'm going to do is I'm going to find the first differences. So 22,400 minus 21 gives me 1,400. And then 23,400 minus 22,400 is 1,000. And then the last difference there would be 600. So those are not a constant, so it's not linear. The difference between these two would be 400. And between these two is 400. So again, since the second differences is a constant, I know this has to use the quadratic regression. So I'm going to go back and I'm going to put this in L1 and this in L2. And I'm going to calculate my quadratic regression. So when I calculate my quadratic regression, I get this, which tells me that my equation is y equals negative 2x squared plus 440x, and my c is 0, so I don't have to write the plus 0. So next, I'm going to graph it. So I'm going to type this into y equals and get my graph. So my graph is going to look something like this. And then once I have my graph, I can calculate the maximum point. And why do I want to calculate the maximum point? Because the question says, use the graph and equation to find the price that manager should charge in order to maximize his revenue. So now I'm going to go back under second, calculate maximum. So I'm going to calculate this maximum point up here. Now, before you do this, what I want you to do is hit your window button and change your window to where it looks like this so that you can actually calculate your maximum. Then when you do that and you go to calculate your maximum, your screen should look like this. So we know that my maximum is at x equals 109.99, and that his maximum profit is 24,200. So to answer the question, he should charge about 110 per night in order to get his maximum profit of 24,200. Let's try one more. So we have a guy who opened up a new sporting goods business and has recorded his business sales each week. To break even, he needs to sell 48,000 worth of merchandise in a week. Assuming that the sales trends continue, use a graph and an equation to find the number of weeks before he breaks even. So first thing I'm going to do is check my differences. So when I do that, 27,500 minus 25,000 will give me 2,500. 30,250 minus 27,500 will give me 2,750. The next one would be 30,25 And the last one, 36,603 minus 33,275 will give me 33,28. So these are not constant, so it's not linear. So my second difference, if I subtract these two, would give me 250. Then I get 275. And then I get 303. So it's not quadratic either. So next thing we're going to do is try exponential. So for exponential, you want to see if there's a common ratio. So for checking for the common ratio, we would have 36,603 over 33,275. That gives me 1.1. Then I could have 33,275 over 30,250. That's also 1.1. So then I can continue this for the rest of them. And I will indeed get the same ratio. So since the ratio is the same, this tells me that it's going to be exponential. So now in my calculator, I'm going to go and I'm going to type the weeks into L1, the cells into L2, but now I'm going to go and calculate under stat. I'm going to hit option 0, which says exponential regression. So when I do that, this is the equation that I get, which tells me in y equals, I can type in y equals 22,727.15 times 1.1, which happens to be the same ratio we just found, raised to the x. Go ahead and change your window to what you see here so that you can see the graph. However, you may not need to change your window if you're hitting that zoom stat. Zoom stat should automatically move your window where you need it. And your graph should look something like this. Now, the question says, use the graph and an equation to find the number of weeks before he breaks even. So, in other words, when is it at 48,000? Because he spent 48,000. So he needs to break even with 48,000. So if you hit your trace and you just trace along this, you should get that at x equals 8, you have about 48,717.664. So this would tell you that he would break even after 8 weeks. The other way to do this is to use your equation. So we have y equals the 22,727.15 times 1.1 raised to the x. And we want y to be 48,000. Divide both sides by the 22,727.15, and that will give you 2.112. And because we're solving for an exponent, we're going to convert this to log. So we have the log base 1.1 of 2.112 equals x. We use our change of base formula, so the log of 2.112 divided by the log of 1.1 would give us x. And we would get that x is about 7.8, which tells me that he needs 8 years.